Hey, what's going on, guys? Let's do this problem right here. The question is asking electric power is to be generated by installing a hydraulic turbine generator at a site 70 meters below the free surface of a large water reservoir that can supply water at a rate of 1500 kg per second steadily. If the mechanical power output of the turbine is 800 kilowatts and the electric power generation is 750 kilowatts, determine the turbine efficiency and the combined turbine generator efficiency of this plant. Neglect losses in the pipes. So here these are the two questions: turbine efficiency and combined turbine generator efficiency. So to find that, they also give the turbine power and the power generation power right here. But to determine this efficiency, we have to know what is the total mechanical energy, right? So to find that, first of all, we have to know what are the energy exist. Like we have mechanical energy, mean that is combined of kinetic energy and potential energy, right? So if you look at this one is almost motionless, right? So there's no kinetic energy right here. If there's no kinetic energy, here also no kinetic energy, right? No kinetic energy. So if I use this one as my reference point, this distance is going to be 0. So there's no potential energy right here. But there's a height for this one at one point. So we have a potential energy. So we have potential energy right here. So that is the only mechanical energy we are going to have. So if we calculate this potential energy, that's going to give us the total mechanical energy, right? So to calculate the potential energy, we need mass, gravity, and height. Here they have given the height 70 meter, but we don't have the mass. We have mass flow rate, but we don't have the mass. So here what we can do is we can simply take per unit mass. We can calculate potential energy per unit mass. So it means per kilogram, right? So if we take per kilogram, that's going to be just GH, because mgh over mm cancels, and we only have GH right here. So if let's calculate this one per unit mass. So this is going to be just 9.81 times the height is 70 meter. So 70. That's going to give us, if you calculate this one, you will get 687 joule per kilograms, because we are calculating per unit mass. So joule per kilogram is going to be unit. So this is meter per second square, and this is going to be, height is going to be meter, and you get meter square per second square. That is equivalent to joule per kilogram, because joule is what? Joule is Newton meter. Newton is F is equal to m over a. So we know that that is going to be kilogram meter square per second square, and here kilogram cancels, so we get meter per second square. So that is equal to joule per kilogram. So that's how we got this one, joule per kilogram. Since we have this one, but it's better to change in kilojoule because we are dealing with kilowatts right here. So let's change this one into kilojoule. So this is going to be, all we have to do is simply divide this one by 1000. So that's going to be 0.687 kilojoule per kilogram, right? Now we calculated the total mechanical energy, but we have to know this one in terms of watts. We have in terms of kilojoule per kilogram, and they have provided the kilogram per second, that is mass flow rate, and we know that for watt the unit is joule per second. If you to get this one, what we have to do, if you multiply this potential energy times so potential energy per unit mass, so let's put a dot for this one, per unit mass times this mass flow rate, so that's m dot, and that's going to give us the total mechanical energy produced in terms of watts. So let's say this is mechanical energy per unit time. Maybe this is not a correct representation. Type per kilogram, right? So PE or kilogram. So this is per unit time. This is also per unit time. So we put dot for the unit time, per unit time. And here we have calculated this one. That's going to be 0.687 kilojoule per kilogram times, but the mass flow rate is 1500 kilogram per second. And if you notice kilogram cancels, we get the unit in terms of kilojoule per second. That's going to give us kilowatts, because we know that joule per second is watts. Kilojoule per second is going to be kilowatts, right? So from this one we can find the total mechanical energy produced. So let's calculate this one. If you calculate this one, you will get 1031 kilowatts. So this is going to be the total mechanical energy. To determine the turbine efficiency, all we have to do is, so let's call turbine efficiency eta turbine, right? Eta turbine is going to be simply the turbine power, that is 800 kilowatts, and over total mechanical energy, that's 1031 kilowatts, and that's going to give us turbine efficiency. That's going to be equal to 0.776. And if you want this one in percentage, you can multiply this one by 100, and that's going to give us 77.6%. And now also they are asking combined turbine generator. So eta turbine generator is going to be the same equation, but for this one we have to use this power generation, this power right here. So that's going to be 750 kilowatts divided by the total mechanical energy power, that's 1031 kilowatts, and that's going to give us 0.727, right? 727 multiplied by 100, that's going to give us 72.7%. And that's how we do this kind of problems. So these are the two answers. So let's box this one. So these are the questions: eta turbine efficiency, and turbine generator efficiency, and that's how we calculate this kind of questions. I hope you guys find this video helpful. Thanks for watching.